Unit 4, Section 13.1 Worked Examples. On the graph to the right, can you determine a path that includes all the edges without using any edge twice? If so, determine such a path. Remember, a path does not have to start and end at the same vertex. This is a multiple choice question, so they've given me 3 possible paths and then also an answer of no, it's not possible. So let's take a look at the paths that they provided and see if any of these would be correct. So they want us to get a path that goes through every edge exactly one time. So if we look at the first one, it says start at D. So if I start at D right here, and then I go to B, let's go ahead and trace it on here. So I'm going to go up to B, and then it says go to A, and then go down to C, and then it says go back to D, and then go to F, and then E, and back to C. And actually that one would be correct. If we look at some of the other ones, we'll notice that they actually take 2 edges twice. For instance, in C, if you look here, you can see in the tracking that CD is included 2 times. And if you look at the one in answer D, it doesn't include all the edges. So the correct answer for this one is choice A. And I should mention in the next section in our class, we're going to learn some ways to determine whether or not there are this type of path and this type of circuit also without having to just guess. So we'll have some theorems to work with. The diagram on the right is a floor plan, letting vertices represent the room and the outside and the edges represent the connecting doors. Which graph correctly models the floor plan? So we see there are 6 rooms, A, B, C, D, E, F, and we notice that rooms B and also room E and F open to the outside. So we want to make sure that we see exits to the outsides from those rooms. And if I look at the first answer on the left side, I notice that it shows that room B is connected to room F right here. And if I look in the picture, that's not correct in the picture. Room B is not connected to room F. If I look at the second choice on the right, I see it showing B connected to C connected to F, and so therefore this is the correct one. And also notice it's showing that from room E we can go outside, from room F we can go outside, and from room G we can go outside. So that's the correct graph. Determine whether the graph is connected or disconnected. So in this case, a connected graph, remember, means there's a path to connect every pair of vertices. If you notice here, if I pick, like for instance, A and C, vertex A and vertex C, there is no way to move from one of those vertices to the other, going through the edges of the graph. So this is going to be a disconnected graph. A connected graph is shown below. Again, that means between any pair of vertices there is a path. Identify any bridges. And a bridge, remember, is an edge. If I remove it, it creates a disconnected graph. And if I notice right away, right here, EF, I see as a bridge. If I take that edge out, I'll create a disconnected graph. So the edge of EF would be the bridge that would create a disconnected graph.